Your agents should be durable, and we'll talk about what is a durable agent, what does having a durable agent mean, what is durability. Show of hands, I like getting a temperature check. Who's heard about temporal? Okay, maybe like 25, 30%. The ones who raise your hand, who's used temporal to build AI? Okay, only one. All right. Hopefully after this, it's your maybe your process has changed and you realize, hey, maybe I do need temporal. Why? Because my agent should be durable. Quick intro. My name is Melissa Herrera. I'm a developer advocate at Temporal. I've been there since September, and my pure missions since then has just been talking about Temporal in the context of AI. The reason being is that Temporal was founded back in 2019, so we kind of predate the AI boom, contrary to some folks hearing about Temporal these days and seeing all of our content with AI. They think that we just came in the AI conversation, but we've been around. And we've been around talking about the distributed system failures that have been existing for many, many years and tackling those. And we've realized that, hey, these distributed system failures apply to the agentic system, agentic production failures that we are seeing today, and they apply to both reasons, and temporal works for both. We'll learn about why. I'm also a dog mom and a matcha lover. I know there's a lot of matcha places here in the South Bay, so if you want to reach out to me for some recs, let's talk after. Okay, I'll start off with a little story. I guess for folks who are building agents, they know this story already. When you're building an agent, you think, yeah, building agents are easy, right? Let's build an agent that will help me search, do a deep research. So the agent goes, hello, how can I help? You say, perform deep research about context engineering. Agent goes, okay, I'll perform deep research for you. Let's consult my brain, my LLM. LLM says, hey, go grab a tool. The agent goes, okay, wait, my brain says I actually need more clarification from the user. Let's ask the user more questions, bringing in human in the loop. Hey, what about context engineering do you want to learn? The agent asks the user. User says best practices about context engineering. I'm sure there's more context that it might need, but we'll leave it at that. AI agent goes, got it. I will go off and do a web search. So this is a bit of a condensed example, but we have that the agent talks to its LLM. We're already spending some tokens there. Maybe it's giving a lot of information about what topic it wants to learn, stuffing in that into a context window, and then crash. Something happens to your agent, whether that's the server crashed, your connection with the agent has crashed. And what happens after that? We're back to the beginning. Hello, how can I help? And now the user is frustrated because all of that information and context that it already gave to the agent is now gone. And we wasted tokens, we've wasted time, and now we're back to square one. So I'll append to my beginning statement that yes, building agents might be easy in concept, but making them production ready is hard because of all of these issues. If we bring that deep research agent into production, what issues might we face? So long running tasks, these agents can execute minutes, hours, even days, from things between your codex agent or your cursor agent to booking agents. Rate limits, so these agents don't just talk to themselves or get their information from anywhere, they get them from LLMs, which can throttle mid workflow and you can hit these limits. Multiple user requests, so as you scale up these agents, how are we going to handle these high traffic scenarios? Ray was talking about how we scale up compute. And then system failures, like I described in the demo right before, the example right before this, just losing the progress, wasting resources, and just unfortunate crashes that might happen. So what do you need in those use cases? You need temporal, because temporal handles all of those issues and it makes your AI agents durable or able to withstand any of these issues that might occur. So who are we? We are a durable execution platform. I'll talk about what durable execution means soon. But we're a fully open source platform, and our philosophy is that developers get to code the happy path, so focusing on only the business logic piece, while temporal handles all of the distributed system failures. So failure cases, error handling, all of those additional lines of code. If you built it in temporal, then it's handled automatically. And we like to meet the developers where they are, so we're available in these SDKs. We have a self-hosted version as well as a cloud version, and they are both open source at its core. And so what is durable execution? I say that durable execution means that it guarantees your code executes all the way to completion, even in the face of these failures. What does that mean for you as a developer who is building these applications? That means your application can survive these crashes and restarts. If those crashes and restarts were to happen, it just resumes exactly where it left off. It maintains state automatically. Temporal handles your retry safely, allowing you, now I know what you mean, the last speaker, not allowing for your applications to run for these long-running tasks for days, weeks, and months. Another way to think about it is a checkpoint in your code as if you were playing a video game. So imagine you're playing in a level of a video game and your younger brother just unplugs your console. And halfway through the level, you're almost about to beat the boss, and you plug it back in and you've lost all that progress. Sucky situation. So think about temporal handling those that checkpoint, but for your code. So now let's take that example that we just saw, but now it's a temporalized agent. So we're at the step where he says, got it, I'll go ahead and do the web search. The crash happens. Temporal is implemented, so the agent goes, what happened? Oh, right, I decided I will do a web search. Is able to replay all of the progress that happened up until that point, and then continues from where it left off. Let's see a live demo of this in practice. So I have my workflow here. I'm using the Python SDK. So implementing temporal is really just all code. We add these decorators to define certain activities, which we'll talk about in a second. And then we use another decorator to define the actual workflow. So this is the workflow that's managing the actual process to talk to the agent. And what that looks like here is, so on the left side, I have our agent interface. On the right side, this is our temporal UI. So deep research agent is asking what you'd like to research. Any topic, what do we want to research? Anything? What are we curious about? Okay. Graph databases. Testing. All right, so it's going to go off and look into that. And on the right side, we see that a workflow has kicked off. So workflow is running. We see that we've started the communication with the agent. It's invoked the model that's basically asking us the clarifying questions. So it's coming back to us for more, asking for more information. So what specific aspects of graph databases are you interested in? Let's just say implementation. And as I send this response, you're going to see another activity appear on the screen. So the temporal UI shows each step of the process. And then it's asking, do you have a particular graph database in mind? No, just tell me about them. Typing and holding a mic is hard. All right, so that second clarifying question just came in, but now this one turned orange. Why is that? Let's click into it. So what's happening here is actually simulating a failure. So that failure could be a network blip, that could be a rate limit that just hit. And what temporal is doing, it's automatically retrying that specific activity that just happened there. The workflow is still running, it's just doing the retry in the background. And in a second, you saw that it was able to come back up, turn green, and now it continues for the rest of its process. So it's withstood that network error. The workflow itself didn't crash, and the user, importantly, didn't see anything happen on their side. So now we continue, right? Are you looking for theoretical insights? Let's just go on with it. Let's say both. Cool. Now our agent is going off, and it's going to do more work. It's going to generate the final report for us with the research. So it's actually calling OpenAI's image gen, and then it's going to spin off a bunch of parallel agents to actually go off and do the research in a second. Just like that. So I'm going to do another thing. I'm going to actually kill my agent process. I went in here and I killed it. And now everything's turning orange. The worst nightmare, right? But the workflow is still going. Nothing has crashed. On the agent interface, I'm not seeing anything happen as a user as well. That's really the beauty of temporal. So I can go back in here. I'll start my worker back up. And this part's really cool. So it's all orange. It's going to continue retrying itself. And once it's realized that, the worker is back up and running and can execute my code again, we should see that everything will slowly turn green. And just like that, everything is recovering. It's recovered from that crash that just happened, and it's able to continue all the way to completion. And so that's durable execution really at its core. So this last agent right here, after it's recovered from going off and doing its research, it's going to write the final report, coalesce all that information, and soon give that back to us. So I want to call it. There's a lot of several other things that are happening here. Published workflow event. I just hosted an event yesterday with a few other folks. Oh, there's the report. Here's the image, and it gave us a nice report about graph databases. So cool. I'm going to read that after. Maybe it mentions trust graph in there. We'll see. But as I was saying, there are a few other events that are happening here. I did a meetup yesterday with Neo4j and Red Panda Data, and it was a cool combined demo that we did where they integrated their tools into a temporal workflow. So you can see how easy and kind of agnostic that we are. Temporal kind of orchestrates pretty much anything. And they integrated Red Panda to publish these workflows into their interface so that they can do analytics further on the data after the workflow has completed or while the workflow is going. In the beginning, we see that they also implemented a knowledge graph search. So, if you already had a graph database markdown report already generated, instead of doing this whole thing, it took a while, right, to do the whole report. It can just grab from the database. So you can integrate a lot with temporal. At the end of the day, it's just code. So that was the demo. And so going back to just the core concepts of temporal. So you saw I was saying things like workflows. I brushed over activities. So workflows is everything that you saw, the orchestration from start to finish, the happy path, as I called it earlier. It's coordinating and orchestrating the main process. Activities are where the unreliable operations live. So those are your model calls, those are your database calls, that's your streaming to the Red Pandas and other analytical services that you might have. Those are the things that need to be retried, and that's what temporal handles automatically. And then finally, the worker, that's what I killed. This is the compute layer that actually is executing your workflows and your activities. So you can scale up or down. So the traffic issues that I mentioned earlier, if you just add more workflows depending on your workload, your more workers, then your workers will take care of that itself. If one worker were to die, if I had 2 workers running and I killed it, the other one can pick up the slack for that worker that just died. And these are pretty much the 3 core temporal primitives. And so, yeah, this is the concept of durable execution. So you see your AI agent is built on your favorite language's SDK here in temporal. And then it talks to the temporal service in which we handle all the queues, timers, retries, all the things that you kind of string together with several other tools. Again, available in either self-hosted or cloud. And so just to wrap up what you just saw in the demo, we saw the temporal UI displaying how we have visibility into each step of the workflow. We saw crash recovery, the workflow resuming from either the network failure or the crash when I killed the worker. Handling the retries automatically. So again, simulating maybe a rate limit hit or network failures, transient errors. And lastly, the simple integration. So working with the tools that you use, the code that you're already building in. That's really the beauty for temporal. And so to just conclude the final statement, building AI agents is easy. Making them production ready is hard, but temporal makes your AI agents durable. And that's why your agents should be durable. Oh, thank you so much. So what you just saw is available on GitHub if you want to run the deep research agent yourself and configure Neo4j if you already have it, or Red Panda if you're already using it. There's options to toggle that. And we also have our community Slack where you can go in and ask us questions. We have people from all different teams in there that hang out. And finally, this is a shameless plug. Oh, sorry. Were you still taking the photo? Yeah, take the last photos. Awesome. And shameless plug, Temporal hosts our annual convention or conference replay in May, May 5th and 6th of this year. So for those who are here present live in the meetup space, you get a special code, SF Community 775, for 75% off of your ticket. So if you're interested in going, learning more about durability, we have a really great speaker lineup of our own customers. Our customers span from Airbnb, Snapchat, Pizza Hut to OpenAI. Their codecs and their image gen goes through us as well. So we have a really great program planned for you all. And this is where to connect with me. If you have any questions, I'll be around. I have some temporal colleagues that are here too, so feel free to ask us questions. Thank you so much for having me.